Ah, such a beautiful flame and a warm light from a kerosene lamp. And by the way, did you know that the first kerosene lamp was constructed by the great Polish inventor Ignacy Łukasiewicz in 1853 in Lviv? But today's video isn't about kerosene lamp itself. It's about what, besides providing light, kerosene lamp was used for in Soviet Russia in 1960s and even further. Today we're gonna talking about great and beautiful device which was called TGK Thermoelectric generator, and of course we're gonna build one. The TGK generator was nothing more than a thermoelectric generator of electricity utilizing the Seebeck effect to generate voltage. As I mentioned in the introduction, the heat source in this case was kerosene lamp. Produced in the USSR in the late 50s, before rural electrification, it was designed to power a radio receiver with electricity using the heat of kerosene lamp. This allowed even the most remote villages to let Soviet residents know what their leader had to say and therefore what to think about a given topic. The generator utilized the Seebeck effect, a thermoelectric phenomenon that involves the generation of an electromotive force in a circuit containing two metals or semiconductors when their junctions are at different temperatures. Discovered in 1821 by the German physicist of Estonian origin Thomas Johann Seebeck, this phenomenon is used in thermocouples among other applications. Those who know me know that I've been a fan of space exploration since childhood, so for me the most interesting application of thermoelectric cell was using them to power the Voyager 1 and 2 probes. They are the only human-made object to have ever left the solar system, and right now they are in interstellar space, and their radioisotopic thermoelectric generators powered by plutonium dioxide constantly power the onboard electronics. Of course, the main components that generate voltage in this case are Peltier cells. However, it is important to note that there are two types of such cells. One, the TEC, which means thermoelectric cooler, is more suitable for building portable refrigerators. The other one, the TEG thermoelectric generator, is ideal for this project. TEG cells generate higher voltage at the same temperature difference as TEC cells and are also more resistant to overheating on the heated side. Okay, now that we know that the TEG Peltier cells are better suited for our project, we can get to work. I'm starting work on my thermal generator by crafting an aluminum component to which the Peltier cells will be glued. This serves as a supporting structure for the entire thermal generator. I constructed it by joining two aluminum housings which I salvaged from old switching power supply. Next, I placed the Peltier cells on a support structure, 2 cells on each side, for a total of 8 cells. Before gluing the cells to the structure, I applied thermal paste. Heat transfer is key in this project. We want as much heat from the lamp's flame to be transferred to the cells as possible, which will reduce kerosene consumption, of course. At the same time, we also want as much heat to be transferred from the cells as possible, but more on that in a moment. But of course the thermal paste doesn't adhere the cells to the structure itself. This is achieved using a high temperature resistant adhesive. This is what the construction looks like with all 8 Peltier cells glued in place. As you can see, the cells are secured with adhesive tape until the glue dries, and meanwhile I can start making the heat sinks, the key elements that will absorb heat from the Peltier cells. The 4 heat sinks, those directly attached to the Peltier cells, were made of stainless steel. The top heatsink, which is essentially the flame deflector, was made of aluminum. Of course, it would have best been to make all the heatsinks from aluminum, however I used what I had on hand. As you can see, the heatsinks consist of 4 stainless steel plates. The largest plate, which will be in the direct contact with the Peltier cells, measured 17 by 10 cm and each subsequent plate is 1 cm shorter, resulting in the smallest plate measured 14 by 10 cm. All 4 metal plates will be connected to each other using 2 rivets, as you can see in the video. Of course, don't forget to apply thermal paste to each plate first. As you can see, I'm making 2 additional holes of larger diameter. These are for threading the clamping tape, through which the heatsinks will be pressed against the Peltier cell. While I was making the heatsinks, the glue I used to attach the cells to the support structure dried. Now it's time to figure out how to connect the structure containing the cells to the kerosene lamp. For this purpose, I first made a slight modification of the kerosene lamp itself by bending the plates to support the lamp shade. From a piece of sheet metal, I made a cover that fits over the lamp's burner. Of course, I didn't forget to make holes to provide combustion air. Then I attached the same plate to the structure containing the thermoelectric cells using rivets. This is how I solved the problem of placing the thermogenerator above the kerosene lamp burner. Of course, the structure containing the Peltier cells will be connected to the lamp with safety wires. And now it's time to make some electrical connections. I will connect all the Peltier cells in series. This means that the positive of one cell connects to the negative of the next, and so on. This will allow me to achieve a higher voltage across the entire cells pack than that of even a single cell. After making the aforementioned connections, I can begin attaching the heatsinks to the cells located on all sides of supportive structure, of course remembering to first apply thermal paste to each cell. As I mentioned in a video when I'm building the heatsinks, they will be pressed onto individual cells using a steel cable tie. That's why I drilled 2 additional holes in each steel plate. And this is what it looks like after putting everything together. I think it turned out pretty cool, maybe a little steampunk-esque, at least in my opinion. Of course, the red wire is positive and a black wire is negative voltage. In the meantime, I've prepared a voltage stabilization circuit. Even though the output voltage from the Peltier cells is DC, its value will likely fluctuate depending on the thermal conditions of the Peltier cells. My voltage stabilization system consists of 3 parallel connected voltage boost converter and a voltmeter measuring the input voltage to the converters. In other words, the voltage generated by the thermogenerator. Why did I choose a circuit with step-up converters? Because I don't want to overhaul Peltier cells. When I started working on a project, I had 10 cells, but 2 had since been damaged. So, not wanting to risk overheating them again, I decided to reduce the heat supplied to them from a lamp burner, thus saving a lot of kerosene, by the way. At the same time, I didn't risk damaging them again. So all three converters were driven to output 5.5 volts, which is a suitable voltage level for powering a small FM radio and of course charging a phone. That's why the output of the entire circuit includes a cable with a USB port. Okay, now it's time to see if a generator built this way can actually be useful. First, I would try powering a small FM radio. After all, as you may remember, that's exactly what the original TGK thermogenerator was intended for, powering radio receivers in the non-electrified territories of Soviet Union.
FM.
Oh. The first test passed. The generator is capable to powering a small radio receiver, and I am completely satisfied because when I built the generator, the minimum assumption was to power a small FM radio. Now let's try something more challenging. Can we charge a smartphone using this device? For this purpose, I decided to add a digital voltmeter to monitor the voltage at the output of the converter, the one that goes directly to the USB socket on the phone. Okay, and we are finally here. That's all in this video. Thanks for watching, I hope you enjoyed it. Nevertheless, I had a bit of hard time during building this thing, especially heat sinks. But nevertheless, it turned out pretty well in my opinion, and the most important thing, it actually works. So if you like what I'm doing, please subscribe to the channel, leave a comment, give a like, and see you soon in the next video on DIY Retro channel.